So we've been talking about the methods and the tools. How about the countermeasures? Let's take a look at those. How can you detect session hijacking? Well, the manual way is to just start sniffing. Or you can use intrusion detection, intrusion prevention. That's probably your best bet, because that can be watching for signatures and watching for IPs that change and MAC addresses that change and weird requests. What can you do to protect against session hijacking? Well, do everything that's encrypted. Don't do anything clear text, first of all, especially things like SSH and HTTPS that require digital signatures. That'll help a lot. And make sure that any authentication cookies, if you are a developer, are passed in an encrypted session, not a clear text session. Encrypt the data that is in transit and encrypt the data that is in use. Use defense in depth. Use the timeout method, if you're a developer, to kill a session when it's expired. Don't let it run forever and somebody sits down at a machine that the user has walked away from. Ensure strong authentication. Make sure that you have maybe peer-to-peer VPNs. Ensure that the session ID is generated after the user has logged in, and only accept session IDs that are generated by the server. Don't let the user or the hacker predict the session ID. Ensure that there are different accounts that have different usernames and passwords. So don't allow one account to have multiple usernames. Ensure that employees are educated and remote access is limited. Make sure that session keys are long and random, so they're hard to predict. Avoid transporting the session ID in a query string that could be just sniffed out. Use switches instead of hubs to sort of help limit casual sniffing. Make sure that you have active client and server-side protection software and that it is updated. Make sure that the user can end their session using a logout. They don't just simply close the browser, because closing the browser doesn't necessarily log you out. Make sure that you have appropriate rules against spoofing, both internally and externally. You've got it on your routers and your firewalls. Make sure that you have intrusion detection, and you have things that are watching ARP to make sure that we're not poisoning ARP caches. And just again, make sure that you use some kind of encrypted connection like OpenSSH or products that use OpenSSH. For web developers, again, make sure that the session keys are long random strings, not predictable. Make sure that after the login is successful, regenerate the session ID to validate it. Encrypt the session key and all data that's being transferred. When the user logs out, make sure that session actually ends and is expired. Don't allow any eavesdropping on the network, and minimize the lifespan of a session or a cookie. So when I log into Amazon, if someone steals my cookie, they can't come back for days and keep on ordering stuff with one-click pay. For web users, avoid links that come in email or messages or on Facebook. Use firewalls to stop malicious content from getting on your network. Restrict cookie use by firewall and browser settings. Make sure that the certificate for the server actually has been signed. You don't get a message saying the publisher of this site is unknown. So don't go for any of that. Make sure that certifying authorities have actually certified the website and that it's current. You'll get messages in your browser if otherwise. Make sure that history and cookies and offline content are cleared from the browser after you've done every sensitive transaction, like a banking transaction or a purchase. If you're transferring sensitive data, make sure the website is insisting that you use HTTPS. And always click the logout button rather than just closing the browser. Now you can, of course, use IPsec, which is a tunneling protocol. It's a VPN protocol that can be used across the internet, and it can also be used between machines in a LAN. This is something that your network administrator, your server administrator would have to set up. But the thing about IPsec is that it's meant to secure IP communications no matter if they're TCP, UDP, or whatever the payload is. They will both authenticate and encrypt every IP packet. Now, the thing about IPsec is that both the server and the client have to use it. So this is more of a corporate solution than just a general public solution. The benefits are you have data integrity, you authenticate where the data came from, there is network level authentication between the two machines, you have data confidentiality, and you can't replay the data either because it's digitally signed. IPsec has basically two main protocols. There's authentication header and encapsulated security payload. Authentication header's job is to digitally sign the IP header. That's its job. Encapsulating security payload is to digitally sign the payload and then also encrypt it. So AH alone only does signatures. ESP does both signatures and encryption. And IPsec has two modes. Now, really, this is more of a server or a network question here. But if you just use authentication header, what you're doing is you are signing the IP header. And then you've got the TCP or the UDP, whatever, and the data. If you use it in what's called transport mode, this is from client to server. And so client to server, we're digitally signing the IP headers. It cannot go through any network address translation. It'll break the signature. If you use encapsulating security payload, ESP, you are not signing the IP header. Instead, you're signing the data payload. And what they do is they slip in what's actually a UDP extra header into the payload, and they sign that. Now, ESP can go through network address translation, no problem. But AH cannot. So if you go peer-to-peer, it's called transport mode, whether you're doing AH or ESP. And by the way, you can do both at the same time. If you go router to router, then that's called tunnel mode. And router to router, tunnel mode, actually puts a new IP address on the outside. It's like an envelope with a new address. And all VPN protocols do that, at least the ones that are below, like, say, SSL. So IPsec has these components. There's an IPsec driver that starts the IPsec session. There's a small protocol called IKE that is used to exchange keys between the two ends. There's something called ISACAMP, the Internet Security Association Key Management Protocol. It works with something called Oakley that keeps on rotating the keys. There's a policy agent that makes sure that if there's a policy requiring IPsec, that it actually is launched by the client and or the server. And I have to tell you that IPsec really, at this point in time, is not a general public on the internet client-server technology. It requires a lot of setup and some infrastructure. So it's more like between clients in a corporate environment where they can control and set policy, or it's between different servers. But in a secure environment that is not public, IPsec is used all the time. So those are some of the most common hijacking countermeasures.